Hey, geometry students, today's lesson, we're actually starting chapter 2 today. So you guys last week have taken your chapter 1 exam, so now your assessment, we don't like the word exam, but today we're starting chapter 2, and we're going to talk about conjectures and counterexamples. So really today it's conjectures, and then tomorrow's lesson will be counterexamples. So a conjecture is when you use inductive reasoning, which is reasoning that uses information from different examples to form a conclusion or statement called a conjecture. All right. So essentially you're going to be given a pattern. You have to decide what that pattern is, and then the conjecture is what is the next symbol or the next number in the sequence or the next figure. So we have two examples here. So example 1 says that write a conjecture about the next number in the sequence. So we have 1, 3, 9, 27, 81. So they came up with a pattern, and the thing about these is it can be multiple things. It doesn't always have to follow one rule. So sometimes there's more than one answer. So each number is a power of 3. 3 to the 0 power is 1. Anything raised to the 0 power is 1. 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. So their conjecture is that the next number would be 3 to the 5th, which is 243. That all works. I think that there's actually another pattern here that we can look at. So 1 to get to 3, I multiply by 3, right? So times 3. Put it in parentheses. 3 to get to 9, what did you do? You multiplied by 3. See what's going on? 9 times 3 is 27. 27 times 3 is 81. So then we could do 81 times 3, which is 243. So my pattern would be multiply by 3. And my conjecture is the next number will be, so I'll put this in a type box. The next number will be 243. So that's one way to do it. Look for a pattern here. So we have one little square, and then we have 4 squares, and then we have 9 squares. So we can look at this as numbers, or we can look at this as sides. If you look at the sides, so the sides of the square have measures 1, so 1 square, 1, 2, 1, 2, 3. So if the first one is 1, second one is 2, third one is 3, what's the fourth one going to be? Well, it's going to have 4 squares. So the fourth one is going to be one big square. 1, 2, 3. So the fourth one is going to have 4 sides. 1, 2, 3, 4. And then after that would be 5, and so forth. So let's look at a couple examples together. Write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next item. So negative 5 goes to 10, 10 goes to negative 20, negative 20 goes to positive 40. So something's going on here. They're alternating positive and negative. And so what do we know about in mathematics is when you multiply two negatives, you get a positive. So we know that what's going on here is we're multiplying by a negative. So we're going to multiply by negative. So what do we multiply 5 by to get 10? That's right, 2. So 5 times negative 2 gives us 10. And then 10 times negative 2 gives us negative 20, and negative 20 times negative 2 gives us 40. So do you think that we found our pattern? So if that's our pattern, then our conjecture would be 40 times negative 2, which equals negative 80. So negative 80 would be our next term. I'm going to give you a heads up here. I'm not going to give you the answer for 3, but I'm going to give you a little heads up. 1 can be written as, 5 over 5. Remember, 5 over 5 is 1. So 5 over 5, 6 over 5, 7 over 5, 8 over 5. You should be able to get the next one. Write a conjecture about each value or geometric relationship. So in this situation, you're actually going to want to graph these points, and not you don't have to do it so that it's perfect, but you want an idea. So if we were to plot these points, negative 1 would be right here. 2 would be here. And 4 would be here. So if I were to draw a line through these points, you could see that these points all line up. Now, if we didn't draw that line, some of us might have said our conjecture is that this is a triangle. 3 points, so it has to be a triangle. In fact, that was one of my thoughts. 3 points usually means a triangle, but in this case, it's not a triangle. We plotted the points, and we noticed that they're all in the line. So our conjecture, we have a term that we've learned. So our conjecture is, we learned a term when points are in the same line. They are called, starts with a C, collinear. So our conjecture is A, B, and C are collinear. There's 2 L's, I think. So that's our conjecture. A, B, and C are collinear. Angle 1 and angle 2 form a right triangle. So what we're going to start off with is we're going to draw a right triangle because we know that they form a right triangle. Ooh. So that's a right triangle. And then they said angle 1 and angle 2 form. So we could say that this is angle 1, this is angle 2. So now we have a diagram of what's going on. So now what can we say about angle 1 and angle 2? Well, they form a right triangle, but we have a term for that. So our conjecture, I'm just spelling it out for you this time because normally I would just put the C. Our conjecture is angle 1 and angle 2, if they form a right triangle, that means angle 1 and angle 2 are complementary. Complementary. So that's how you do it. I'm going to draw the diagrams, and then you guys can make your conjecture for these two. So we have vertical angles, so that would mean, so then we would have, label these, this is A, this is B, this would be C, this would be D, and this would be E. So what you would need to do is you would need to mark the vertical angles here. You would mark the vertical angles, and then you tell me something about vertical angles. And you have to look into, so chapter 2 is all about remembering the definitions that we've learned. So vertical angles, I'll give you the hint. There's certain thing about vertical angles that all vertical angles follow. So that's what you're going to have to look at. So angle E and angle F are right angles. So notice that, so angle E, hold on. So this is angle E. It's a right angle. And this is angle F, is a right angle. So because they don't give us a lot more information about that, what you need to look at is, what is a right angle? What is there to know about a right angle? And then, okay, so once I know what a right angle is, well, I have two right angles. What can I say about them that they're the same? How can I say that? And that would be your conjecture. So you guys have just finished out 6 and 7, and you have 2 and 3. So 4 problems for this assignment. Any questions, reach out. Thanks, guys. Have a great day.